Hello, welcome. Good morning, good evening, good afternoon, wherever this video finds you. We're going to go ahead and start talking about lists. Um, and now, there's two things about lists that I want to be kind of clear about, and that is, kind of a little bit of knowledge of how a list is actually what we call an array in other programming languages. So you will actually hear me use list and array interchangeably because actually a list is implemented at the C level as an array. So we'll be talking about a little bit of how that's structured and how it works and some of the limitations for a list. and it's loosely based with an array because there are more limitations to a C-based array than there are for when I say C-based array, I mean there are more limitations to other types of lists because the list that you have in Python, I would kind of refer to it as a super list because it doesn't have as many limitations as other programming languages have. So we'll talk a little bit about that as we progress and discuss a little bit about lists. So the main things that we're going to be getting into is the idea of what a sequence is. And of course, an introduction into what a list is and finding items in a list, some of the built-in list functions, and then of course list slicing, processing lists. What is a two-dimensional list? The things that we won't talk about is a tuple or plotting a list data with matplotlib. A tuple is just a list that can't be changed. So that's kind of, hey, let's create a list that is read-only, one that we can't add to or modify the data inside of. That's what a tuple would be. So we're going to skip over that. And the matplotlib plotting list data, that you guys can play with on your own. I want to concentrate on basically what a list or an array is and how to work with them. We'll do more on how to work with them in a demonstration video. That'll be your second video coming up. So let's go ahead and begin with our PowerPoint discussion. And when we talk about a sequence, we're talking about multiple items together sequentially. Another word we refer to this as contiguous blocks of memory. And that contiguous word is kind of one of the more higher level words used to refer to a sequence. But basically it means items that are in order. Well, how are they in order? Well, they're in order by blocks of memory that are put together. So, and that's how arrays are actually implemented in computer science, is with blocks of memory that are in numerical order by their address. So we often want to take a data type that is the same, and lists need to have the same data type inside of them, or arrays. And so it is possible to have mixed data type arrays, like you can, or lists, but we're gonna keep to the traditional point of an array discussion is that the sequence of data is that they are one after another and that they're the same type of data all together sequentially in your RAM. So they're actually physically together in your random access memory. When we use these terms mutable and immutable, so that's kind of the discussion down here. And the tuple is a list that's immutable, meaning it cannot be changed. Once you create the tuple, it cannot be changed. It's read-only. The data inside of it is constant throughout the process. A mutable list is one where you can actually change the data inside of it. And that's where we're going to be, that's the one that has the most utility, that we're going to be using and working with most often. And one of the ways that you actually will, and I'm going to use a word here called instantiate. That means to create. It doesn't mean to define. When I use the word instantiate, I'm talking about a runtime piece of code. Like when I talk about defining a function, that is both defining the function, but when you call the function, that is runtime. That is when it actually runs versus defining what it is. And you guys will get a better understanding of definition code when we get into objects later on in the course. And you can create a list using the name. You just declare the name. Now remember, in Python, variables are created in how you instantiate them, how you create them. So using this equal statement is actually the instantiation. So we define a variable, and then the way that we define it and assign it is the instantiation of the data type that is stored, or what type of data that variable is. In this case, you notice how we have a square brace around the information inside, separated with commas. So this is how we would have a sequential list of items, or create a sequential list of items with that particular syntax. So let's go ahead and just do a little bit of some demo on this. I'm going to bring up Visual Studio Code. You know what? We're pretty much done with this stuff. Let's go ahead and just use what we did from the previous video. So if I want a list of numbers, I would say I would probably want it to be iList, integer list, and I would then separate it with brackets. This is a tuple. This is an actual list that's mutable, that you can change. Then I would put the items in that I want inside. That would be creating or instantiating a list of numbers. And then I could print that list, and it would show up down below. So here it is. Now notice that the print is outputting each item in the list, but it's also putting out the brackets to show that you're printing out the whole list. We can also use a for loop to print out each item in the list. That we can get into shortly. And actually, let's add that to notes for doing in demonstration mode. Print items in list. In list multiple ways. We may come back to that. So those can also be different kinds of data. It could be a list of words. Now you notice I'm putting the double quotes or the single quotes, but that could be a list of two words together. So the list itself, the way that you differentiate between the different data types that are in the list is how you instantiate the list, how you actually create it and assign it when you use that equal statement. So now we got a list that's called iList. Okay. Let's look at a little bit of the mechanics of how this actually works when we think about contiguous memory blocks. The thing that makes a list in Python so much more valuable than other programming languages is because it is not relegated to handling or having a specific data type needed for each memory location that is the same. So when I refer to an array in a traditional programming language, I'm talking about ones or an array that is, in this case, you can see that even numbers has all just numbers in it. But a Python list has been built, it's kind of like I used the term before, a super list, so that you can have different data types in the list, such as this example down below. And then we have this example where we just have a list of items that are all the same but happens to be words. So mechanically, what does that look like in memory? Well, we don't need to get too far into that because there's certain things that need to happen to make this work so that it handles for multiple data types. But I can talk to you a little bit about how contiguous memory blocks are done with a traditional array. With other mechanisms, we would have to get into kind of a more difficult discussion. But you can kind of think of it this way. Let me bring up the PowerPoint. There we go. So in a traditional array, and I'm talking about other programming languages here now, this would be referred to as a pointer or a reference that would point to a memory location, let's say that's located at address 10. So then this would be at address 10. And then the next one would be 4 bytes up because it's storing integers at address 14, and then 18, and so forth. So then this would reference the very beginning of it. And that's what we would need for the beginning of our list or our array. Python, the mechanics are a little bit more difficult than this simplistic method. And you know what? We don't care. That's something that's built for us in the C level, and we don't need to take the time to conceptualize that, because guess what? This is shorthand programming. It's a higher level language that we don't want to spend the time dealing with pointers. In fact, that's the whole point of languages like Java and C#, is that we don't have to do all the work of dealing with pointers. But here's the problem, is because that work has been done for us, our code is not as efficient. So invariably it is slower. Python is slower than like if you were to write this in a lower level language. However, you can write the application quicker and get an answer quicker. That's what we want to have as like a scientist that needs an answer, somebody that's studying data, or even somebody that's trying to write code for something that's never been done before, like Google did with their search technology, and they changed the world with it. They did that in Python because if you get into the weeds of that lower level language, you're in the weeds and you can't see outside those weeds often, and so you get a better understanding of being at a lower level understanding. So we only refer to these as memory blocks, and we can think of them as contiguous. That's fine, but we can think of them as contiguous in sequence on how we access them. So we access this one at location 0. This one we access at location 1. This one we would access at location 2. So these are the indexes, and we talked a little bit about that in the last video. And we don't have to deal with pointer stuff, and I don't even want to get descriptive on it because we don't even need to get into the weeds. So it's so much nicer to work with because of that, and we can get more complex code done and not deal with the mechanics too much, other than, hey, we've got an index at location 0, we have Alicia. At location 1, we have the number 27. At location 2, we have the floating point number 1550.87. And we don't even care that this one takes 8 bytes, this one takes 8 bytes, this one takes 4 bytes, and this one takes 8 bytes because it's a double. And we don't even care where, even if those are contiguous, or if this is at location in RAM at location 2000, and this one is at location 5000 in RAM. We don't, that's all done for us. So the only thing that you have to worry about is the index. That's what's beautiful about it. And that's why C#, Java, JavaScript, and Python are much more user-friendly languages to work with, and hence that's why it's a cybersecurity analyst. It's in a cybersecurity analyst toolbox or a data scientist toolbox. Somebody that's building a web scraper, like a Google web scraper, because we don't need to deal with the minutia. So that's all you really need to think about, is that, hey, they are together in sequence with the index values. Now we can look at different ways of actually using those index values to process through a list. So let's actually go into demo mode here. And what I'm going to do is I'm going to show you 3 different ways to, we're going to look at this way and maybe one other way, maybe not a third way, but we will see. I think, yeah, let's go ahead and do that. Let's do this first one. This is going to process a list for X in iList. Now, what does that mean? That means we're going to, other languages we refer to this as a for each statement, but this is a for loop for X in iList. That means that for every item that's in the list, what am I going to do with it? And basically what it looks like is X will be a variable that when it first runs through the for loop will point to the first item in the list. Then the for loop runs again and X will point to the next item in the list. Then it runs again, X goes into the next item in the list. Then it runs again and it'll go to the next item in the list, and so forth. So when we actually look at that in the debugger, we'll see that behavior. And what we'll do is we'll just do a print X here. And I'm just going to throw some other words in there. So let's go ahead and look at this behavior of the for X in list running. And this is one of my favorite ways of processing a list in any language. It doesn't matter if I'm using a for each inside of Java or C#. The only problem with it is it's not as fast as the for statement itself or a while statement. But X is assigned to the hello value. And so when we print X, first X becomes, and we see here the iList holds hello world IM. First time through the loop, X points to hello and it prints out hello. Then the loop runs again, X now points to the world value. So you can use this to process a list. because often you would want to process just the items in a list. So now we print X and it's now world. So now the next time this loop runs through, I'm using step over here. It's going to be, X is going to point to I, and we're going to print I. Then X is going to be point to M, and we're going to print M. So what we've done is we've processed each one of those items separately that are in the list. And you will want to do that often for your list items. Now another mechanism that we can do is we can say for X, for in range, for I in range length of X, or length of I list. So what length of I list does is I is a number that just walks through, and length returns the length of the list. So if we look at this in the debugger, let me just do a real quick showing to you here. If I were to select just this expression, length, len is a function that means give me the length of this list. And I right click on it, and I'm going to copy that, and I'm going to go over here, and I'm going to add it to my watch list down here. So I can just see what does that expression actually output for the range option in the for statement. So what does it output? Well, since iList isn't created yet, we're going to have to do a step over here before that code will actually evaluate. So now iList is created, and now the length of iList returns 4. 1, 2, 3, 4. So that means that there's 4 of them. So when we say for I in range length of iList, what we're doing is we're actually saying for I in range of 4. So we're actually saying this, for I in range of 4. But we never know what the length of iList is always at. It could be dynamically done. We could use the list to read in information from a file. So we want to use the length function to determine the length of the list if we are using a for I in range loop to process it. And then what we have to use then is if we're using a numerical value to process it, then we have to use the subscript operator and I inside. Now this is primarily the way I like to process lists if I want it to be faster, because this type of mechanism is a lot faster than the for X in, it just is a little bit more efficient. But again, in Python, you don't necessarily care about speed unless you're doing a lot of data science or web scrapers or whatnot. So let's look at what this actually does. Okay, so we run through it. The first thing through, we say iList of I. So let's actually add a watch for this. Let's select that expression and let's see what print is actually doing there. So iList of I, what is that? Well, it's hello, because I starts at 0 first and it goes up into 4. So the next time it comes around, I then becomes 1. Now when I is at 1, and you know what? Let's add a watch for I. Oh, wait, it's already up here in our locals. Now I is 1, so when we print iList of 1, that means this position right here, world. And so our sequence, our contiguous sequence of memory index is we're using those numerical values to access that sequence of values. And we can use that to process the list just as we used that other form of the loop. Okay, that takes us through some of that. Let's see, we've talked about the len function. Often you have to use a -1 when you're using the len function. When we do the in range, the range function always excludes the last value, so it works here just fine without an error. But if we want to get the full count, we and use the indexing, it goes from 0 to 3. This is at location 0. So truly, this is at location 0. This is at location 1. This is at location 2. This is location 3. So the length of iList is going to return 4. But if you didn't know, range actually is exclusive. So when you send it 4, it actually interprets that as 3. Because of this exact reason, because of the way arrays work in programming, we always treat the first one as 0. Because guess what? When you're actually implementing an algorithm, you can't forget that the actual first one is 0. Your algorithms will screw up. You know, it just is. Because when you actually take something and make it real, you get an understanding that 0 is actually something that you cannot forget about. It's there. And so we always start arrays at location 0. So this will return a 4, but range will start at this will actually, since this is exclusive, this is an exclusive argument, it will actually go from 0 to 3. Okay? Now, when we output this, we should get the same output. Okay, what happens when we do this? Oh, we got an error out of range. Why? Well, we only have 4 items, so that's why we put 4 here, which actually means 3. Because we're starting at 0 and going to the third location. Yes, it's confusing, but you'll get used to it. That's why the len always returns a 4 here, because it's exclusive and it actually means 3. So go from the 0 position to the third position, from 0 to 3. Okay. So we just actually used the length term, the len function for that, to make it work well. We can change items using the subscript operator. iList of 1 or of let's say 2 is equal to changed. Okay, so now instead of this item right here being I, it's going to output and it's going to be changed. So see, we changed the value. We can add lists onto each other using the plus operator. So how could we do that? Well, we could have one list that we add to another list, and we can consider that concatenating. And so what we can do is, let's just do a quick easy one. We can say iList is equal to iList plus iList. Well, what does that do? That takes iList, adds it to itself so that the new one is basically a double list. We output it, and then you see how we output here. But look at what happens there. Since I made the change after the change here after I concatenated them. You see here where we have a difference in values. So concatenation will take the old value added on, or in this case, the old value added to the old value for the new value, but change the second one in, which is this guy right here. And then print them all out because the length of the list is now doubled the size. All right, you can use slicing terms so that you can slice list or from one list to another. So let's say that we want to maybe slice from one item to another. Let's say that we want to say n list equals I list. Let's start at position 2 and end at position 4. There is some inclusive, exclusive differences here that you would have to look at. And then when we print end list, we're going to get some different values. But we can look at it in the debugger and see what it actually does. Oh, I used the wrong syntax here. Excuse me. We used the colon there. So changed M. So what do we do? Well, let's look at what iList is. From position 2 to 4, so we've taken 0, 1, 2 to position 4. From 2 to 3 to 4. But why didn't it put hello in? Well, because the 2 is inclusive, meaning include the 2 position. But remember, we always have that off by 1 error because all lists or arrays start at 0. That's why the last argument is always exclusive, meaning go up to the 4th position, but do not include the 4th position. So it only gets 0, 1. It grabs 2, the 2nd position, and we say go up to the 4th position, but do not include it. So you only get changed M. And that's the thing about using slicing. The first argument is inclusive. The second argument is exclusive because arrays are 0 based. And also there's a reason why we do things this way. And that's why it's because arrays always start at 0. So that's why we have the inclusive, exclusive types of behavior when we're working with arrays or lists. All right, finding items in a list. You can do that with the item in list. So you would use the actual literal of what item is actually in the list. And what this is going to do is this is always going to return a true. So what we can do over here is we can say, hey, oh, that's why I got an error there is because I didn't do length of end list there. That's why it died. But that's okay. It only went so far, and then it died. Let's go ahead and run that and make sure that I didn't lie to you. Yeah, okay. So we still got the same output. That's good. Let's do this. Let's do this. If world in iList. Oh, I got to tab that in. Might be missing something else. Well, you know what? That's fine. I am ready for a break, so I'm going to go ahead and demonstrate this. As soon as I come back, I'm going to take a quick minute coffee break and come back with you, and we're going to demonstrate the in statement and then continue on with our PowerPoint. I'll see you guys in a little bit. All right, welcome back. All right, so I had a real simple issue, which was an indent issue. And guys, the best thing you can do when you got an indent issue is to literally go and backspace it all the way and then tab it in. Because often what will happen is Visual Studio will automatically tab it in for you. You see that? I didn't even have to tab that in. So a lot of your integrated development environments, IDEs, will do that for you, and you can actually add extensions to this that will even guess using artificial intelligence what you mean to write, and you just have to hit the tab key and it'll write it out for you. It's really awesome. So yeah, look into your extensions and play around with that, because especially when you copy and paste code from the internet, you're going to have formatting problems, and often you will paste in character codes that the Visual Studio code doesn't really know how to, the interpreter can't interpret. Even though it looks like a double quote, it won't be a double quote. It'll be some kind of weird esoteric formatting character in Unicode from the internet. And and often, here's the other thing. Sometimes you won't even see it. Sometimes what you'll have is you'll have a character in there you can't see, and you have to go up, get rid of all your white space, and then rewrite the code because you copied and pasted white space where there's actually a character in it that you can't see from the internet. So I would really discourage being careful with that. I actually wouldn't want you copying and pasting anything from the internet as much as possible. From your book, absolutely. As much as possible, that you can. That way you can spend your time, instead of typing, actually learning. All right, so let's look at what this actually does. And what we're saying is, hey, if this item is in the list, print yes. And what we can do is when we run the debugger, we can do a step over, and we can actually just select this whole line, copy it, and evaluate it over here just to see what's going on. Oh, it didn't like my double. Let me do this again. There, without the quote. Oh, it does not like me. Never mind. I think what we need to do is make that less. Maybe that will work. It might not be. Oh, you know what? Let's just try this. World in list. Because I think just that is the expression. You can't put it together with the if statement when you're using the expression itself. So we'll just do world in list. That should return true. Boom, true. Awesome. And then you put the if instead in front of that, and what it's evaluating is what this expression is actually returning. So the expression is the in statement that you're evaluating, and so this is the expression that returns true or false that the if statement then looks at. And then we can do something like not in, and we can say no. Else, there's my silly, I'm going to really mess this up. Else, print yes. Yes, okay. So we can run it again. Step over. Hey, is world not in the list? Oh, it is. So that returns, in this case, this is going to return false. So we put that in the expression. So this is the world of stuff that you guys can do in the debugger to really understand things. Please use the debugger. You guys will save hours and hours of learning and understanding if you actually can see it. Because you can see it in action. You can see the behavior, and a lot of mysteries are uncovered working with the debugger, and your learning will just skyrocket, which is why I do it in demo mode. Just to give you that little extra boost in how to use the actual debugger to learn. Okay, so that's a demonstration of that. Oh, whoops, wrong window. Let's get back into here. All right, so we can use item append. We can append mixed items to a list. Let's look at that real quick. Let's simplify some of this code now. Let's see. Let's do this. Let's mix this up. ilist.append. And this is going to append to the end. And let's put just a number in there. Because, woohoo, this is a list, not an array. That's why we refer to this as a list, even though I kind of tell you it's an array. Yes, they're sort of the same thing, but this is what I would refer to as a super array, because it can handle different data types in its contiguous blocks. Okay, so for x in ilist, print ilist. And so that's going to print out the list now. And what we'll see is we'll see the appended 10 to it. Oh, that's interesting. Oh, I printed the whole list. I need to print X there. Okay, so now there we go. So then we got our append of different data types that we're mixing in the list. Okay. Good. We have done that. Again, wrong window. So index, we can tell where, often what we'll want to know is where in the list an item is actually located. So let's say that we want to know what index number the 10 is located at. And you guys will find a lot of reasons for using this. So we can do this. We can say, hey, print, where is the index? Let's look at the use case here. Index of the item. Index of 10. Now, if I remember right, we got to look at, because you know how we used the append method? We used the list first, because these are actually built-in functions to the list. So we got to use the list's name, its instantiated name, to invoke that built-in function, or to call that built-in function. So what we need to do is, if we want to know the index of item 10 in the list, we got to prepend that, just like we used ilist here dot append 10. We've got to prefix this with ilist and run the index function of ilist to determine where it's located. And what this is going to actually output is it's going to be located at index 4. So when we run it, we should get an output of 4. And here's our output 4 down at the bottom. And that's basically how that works. So often you will need that information when you're working with a list. All right, so this is some of the other added in functions. The sort function will sort items in the list in ascending order. Now let's just look and see how that works with mixed data types. So what I'm going to do is, in our example, I'm going to append it, and then I'm going to say ilist.sort And let's see where it puts the 10, because it's going to do a lexicographic comparison. So is it going to put the number first or the letters first? Oh, it looks like we did. See, there's the problem with Python lists. When we have a mixed list, sort is not going to work. So would sort work if we didn't have a mixed list? So that's a limitation of Python, it looks like. So we can't have a mixed list, which makes sense, because how are you going to take a numerical value and sort it inside of, alphabetical values? They're not comparable on the CPU. Or within, most languages. You would have to convert the 10 to its ASCII equivalent. Now let's do this. What if we had the 10 in its ASCII equivalent? This is why people when you're in a chat, so if it's doing a lexicographic comparison, it's going to use the ASCII code to actually sort things. So the way it should behave is, if we look at the ASCII code, you see that the numerical value 1 and 0 have the values 48 and 49. But an A through a Z is 65 through 90. An A through Z over here, lowercase, is 97 through 122. You can clearly see that these numbers 1 and 0 have lower values than the character equivalents. And that's what I mean by a lexicographic comparison. When you do a comparison, a sort on a computer, it's going to sort the ASCII values alphabetically depending on the ASCII code value. So we should have 1, 0 come out first in ascending, and we see there in ascending values, 1, 0 comes out first because it has the ASCII code values that are lower than your actual character code values using the ASCII character codes. And of course, you can't actually mix this with the actual numerical value 10, because when you look at sorting, these all have to be numbers to sort them, or they all have to be ASCII characters to sort them correctly, or Python can't handle that sort function. We have the ability to remove items from the list. We can reverse the list. We can also use, we can delete a specific item using the subscript, the index numerical value. And here's another thing that you will find often that you will use. What is the min and the max? And how does it work? How does the min and the max work with characters versus numerical values? So let's look at this. So let's do characters first, and let's see if the min or the max of the iList, what it actually prints. And let's just do printing the max of the iList. Make sure that, for some reason, these tabs are really messed up. Okay, there we go. That's a little trick to fix your tabs. World. Why does it print world as the max? Well, does it have to be with the length of characters? Or is it the actual character codes? No, it's the character code values, because W has the highest values. So all it does is, if you do a max of the characters, all it does is count up the character code values of the ASCII code, and it returns the one that has the highest numerical values. So if I had all A's in here, this would be the min. Oh, I. Well, duh, because it's the lowest character. Okay, so it's not only the lowest character codes, but it's the lowest values in the character codes. So it's not only the lowest amount of characters, but it's also the lowest character code values. So what does it return? What does min return? Does it return the A or the I in this case? So this is kind of what you do to learn is, oh, it's I. Why is min I? That is interesting. Oh, because it is not the number of characters, is it? It is actually doing straight up the ASCII code values. Wow, let's look at that. Capital I versus lowercase a. Why is I the minimum? Let's look at the character codes. So it's not the number of characters. Uppercase I has the value 73. Lowercase a has the value 97. Oh, so it's actually the lowest character code value. It has nothing to do with the amount of characters in it for the min or the max. It is only about the amount of values that those characters count up to in its code. So let's do this. To even kind of get a little bit more fun with this, what's going to be the min here? A. Okay, what's going to be the max? AAA. So, oh, it is both. Oh my goodness, it's both together. That gets confusing, doesn't it? Yes, it does. And that's why you got to get in here and play and just see how these things work. Now let's do this with numerical values. 10, 20, 9, 8. Okay, so the max should be 20. This one's easy to understand. The min will be 10. So it can be confusing with the alphabet. So with alpha characters, it's both the amount of characters, but also how much they add up to with their code values. So the min and the max are kind of an alphabetical representation with the number of characters based on the comparison. Okay, now let's get into some more PowerPoint. Copying lists. You know, you can use a for loop to copy from one to the other. You can use the split method. I've already kind of showed you a little bit of that. You can process lists by adding up all the values and dividing by the length of the list. So let's say that we had a numerical values in our list, and let's say we wanted to count all those values up. So what I would do is I would do a for, let's just do in x in I list, and let's have a value, and let's do an average equals 0, and we'll say average equals average plus x. So the first time through, it'll be average will be 0 plus 10. So average will become 10. Then the next time through, it'll be 10 plus 20. And so we'll have 30. And then the next time through, it'll be 30 plus 8. So we'll have a total of 38. Now, what do we want to have for the average? Well, the average then we need to take, and let's put this, it looks like my tabs are going to have some issues here. For some reason, this guy is being a stinker. It looks like my tabs never really got properly done anyways. So I'm going to go and redo them all. And that can happen, guys. That's a big problem with programming. You want them to be lined up on the lines. So you see this line? You want them to be lined up on the lines. So what I want to do is I want to say total average. And this is going to be a floating point, is equal to the average divided by the length of iList. And that's how we can count up the average of a list. And that's for your processing. So let's run this in the debugger and look at it. Okay, we step over. We take, and we can look over here in our locals. Average is 0. X is 8. So it's going to say 0 plus 8. And that's what it's going to assign average to. Now average is 8. So our new average then is going to be, and X is now 10. So it's going to take 8 plus 10. And you can just hover over it, and it shows you what the values are. And my next value now average is 18. Well, that doesn't make any sense. 18, 10 plus. Why did, oh, because we sorted them. I sorted them. So it became 8, 10, 20. And I was looking up here 10, 28. And I was like, what the heck's going on? It's not doing this right. Let's get rid of that sort so I don't confuse you any further. Well, I confused myself, actually. Okay, so the first time, average X is 10. Then we say 10 is equal to 20 plus, or 10 plus 20. Then average becomes 30. Then we take 30 and we add the 8. And now average is equal to 38, which is all the numbers added up, which there are 3 numbers. And we say the length of iList, well, what is that going to output? 3. So that should be the appropriate average. And we have the value 3 point, let's do this, print T average. Okay. 12.6. Okay. 38 divided by 3. All right. That is a little bit on that. Okay, now we're going to get into two-dimensional lists. And for that, I'm going to come back here to you guys in a little bit. I'm going to let you guys play with that. We're going to go right into two-dimensional lists when I come back. So I'll see you guys shortly. All right, welcome back. Let's go ahead and get on to two-dimensional lists, and we will probably call it an end there. Two-dimensional lists are just basically, we refer to it as two-dimensional because each sequence has another sequence with it. So what I mean, you can actually have three-dimensional lists, four-dimensional lists, etc. So for every every sequence, there's a sequence with it. And you can think of it as rows and columns. So the sequence, the row sequence has a column sequence. This is this row sequence. This is the sequence that goes with the column. And so for every row sequence, it has a column sequence. And that can work vice versa. So for every column, there is a row sequence. So they can be interchangeable. And we use specific subscripts for them. And you can see kind of what I'm talking about with for every row. So in this sequence, we have each item located at 0, 0 in the first dimension, but every first dimension location or index has a secondary index. And the way this works is with basically using two numbers, numerical values, to reference a specific value inside of the multi-dimensional list. So let's actually play with this a little bit. Now, we're going to let's get into Google and find some good examples for this. And what I'm going to do is I'm going to do a search for two-dimensional. Got my keys. Two-dimensional list Python. Now let's look at and so you see here it says 2D using 2D's arrays backslash lists. So it's referring to, this website specifically is referring to it also as an array. And let's find a good example of creating an array, a two-dimensional array. And this may be a pretty good example, but you see it's kind of the syntax that is being used. We have an outer brace that is used to represent the first sequence. So you can think of a two-dimensional array list as a sequence of sequences. Yeah, three-dimensional would be a sequence of sequences of sequences. So let's look, and let's just actually play with that real quick, and let's try to do it in a way that's kind of a little bit more understandable. So let's say that we want an initial sequence. So we have our master sequence, our master pointer reference that points to a sequence of sequences. But inside of that master sequence, we're going to have many subsequences. So you see how I'm laying this out? So instead of just a single sequence, we have an array of sequences. that's what, or a list of sequences, or a list of lists. This is a syntax error. Okay, so then I'm going to say for every sequence, for every row, let's say that we have a column that starts at 0 and goes to 2, and this will be like a tic-tac-toe. Then our next row has the column start at 3, 4, 5. Then our next row would be 6, 7, 8. Okay, so how does this work? Well, when we think about this, and let's lay it out a little bit more generically, I'm going to use some comments here. And let's say that at location 0, 0, that is the very first sequence, the 0th sequence, and the zero location is the value 0. Okay, now the first sequence, or we would also say that's the second sequence, at location 0, so that would be then, okay, if we are talking about the second sequence, we are talking about that guy. So this would be the 0th sequence, the 0 here. Then this guy would be the first sequence, this guy here. And then the 0th location in that sequence there. So that's where the number 3 is. Okay, and then the next one is, let's say, this guy right there, 1, that would be 2, 0. That would be the second sequence, and its 0th location. That is the 6. Okay, now let's get in, let's break this down. Okay, so then what's at 0, comma, if I'm doing this right, 0, comma 1. Well, at 0, comma 1, we're going to the 0th sequence and the 1 position. So at 0, comma 1 is going to be the value 1. Oh, I'm mixing these up. Okay, so that's the value 3. This is the value 6. At 0, comma 1 is the value 1. Okay, let's put in the next one. At 0, comma 2, that's at the 0 sequence, at the location 2. So at 0, comma 2 is the value 2. Okay, now that is the first sequence. So then we get into the next sequence. Well, what's at location, we know that at location 1, 0 is the 3. But what's at location 1, comma 1? Well, that would be the 1 location and the second one in it. So that would be the 4. Okay, and then we have 1, comma 2. So at the 1 sequence, the second location, which is the 4. Why do I have a 4 there? Okay, well, I think I'm getting things mixed up, but that's okay. So we have 0, 0, 0 sequence, 0 location. 0, 1, 0 sequence, 1 location. 0, 2, 0 sequence, 2 location. 1 sequence, 0. That's this guy. 1 sequence, 1. That's this guy, the 4. Okay, and then we have, what is 1, 2? That's the 5. And then we have our next sequence. What's at 2, 0? 2, 0, that's this guy, 6. And, oh, I think I just double did 4. I probably made a mistake there. Okay, then we go to the second or the third sequence. It's second one, so the third sequence, that's location 2, 1. Or 2, 0, that's 6. 2, 1 would be this guy. See, I even get mixed up with this stuff. That's 7. And then our last one would be 2, 2, which would be the third sequence and the third value. So remember, 0 is 1, 1 is 2. So this would be the 8. Okay, now when we actually work with it, let's say that we want to print the value 3. So we would put print ilist of 1, 0. And that should output the value 3. Now it looks like my tabs are messed up, so I'm going to go here tab in. There we go. We got that done. Tab in. Looks like that is garbage. So now this should output 3 if everything that I told you is true from here on out. Okay, it looks like I made a mistake. I am going to, it might be a simple syntax error. I am going to look into this and come right back to you guys. I got to refresh myself on the appropriate syntax. I think we could just look over here into the web page. No, it's looking good. Oh, that's what I did wrong. Yes. These actually have to be in separate locations. So these actually have to be separate brackets. So that was the fix there. So notice how I'm using a bracket for the first dimension and a subscript bracket for the second dimension. Now we should output our 3. There's our 3. So we have that done. So then how do we process this two-dimensional list? Well, we have to have a for loop that goes through each sequence and then another nested for loop that goes through each subsequence. So we need to have this for I in range. And I'm just going to hard code this because I know there's 3 of them. We could do this len of, I think we could do this ilist itself. I think that would work because this should return that there's 3 subsequences. And we're going to check that in the debugger. Then predominantly I'm going to use this one, for j in range. And what I can do is I can say len, and since I'm using ilist of I to go through each one of these, I can use this 0 indicator to reference this whole 0th sequence, then this sequence in the 1 position, and then this sequence in the 2 position. And even if maybe I have, let's just throw an oddball in here. Let's do that and see what happens. Even if I have an oddball in there, it should handle this. So what I'm going to do is I'm going to say len of ilist of I. So I will start at 0 first, and this should return numerical value of 3. Then when we get done printing all the I values inside the sub, I will go to the 1 value, and it'll print all the subs from there. And then we go in here, and it'll be the len of the second subscript, and it should return a 4, and then we'll print all the subs. So then what I'm going to do is I'm going to say print ilist of I j. That should work. And what we're going to do in the debugger is we are going to set breakpoints so we can see how this for loop is running. Okay, so we create the list. Oh, I didn't do a debug. Okay, step over. Good. The list is here. Okay, now we say for the len of ilist. Now let's actually add a watch here for this guy, so that we can keep an eye. Let's get rid of all these other. Oh, we already got the watch there for that. So you see it outputs 3. So now what I'm going to do is I'm going to say, okay, what is the length? Because when I refer to ilist of 0, so let me throw in here. When I'm thinking about ilist of 0, what I'm referring to is this guy right here. Well, what's the size of IList of 0? Well, IList of 0 has 3 items in it. And that's why you get a return of 3 here. So then this loop, what it does is, for all the 0 items in I, it's going to print all its j items inside of it. So I is 0. So at location 0 of I stays 0 throughout this whole loop. And only j increases in value. So j starts at 0. So IList of 0, 0, that's referring to this guy, 0, 0. This is the 0th item, the 0th item in the subsequence. So when we say I is 0 and j is 0, we're outputting 0. And so we output 0. And here's our output 0. Now the next time through the loop, we see that j increases by 1. But you see here, I is still 0. So we output 0, 1. So now we're saying go to the 0th position of IList and output its first item in the sublist. And so now we print the 1 value. And it looks like I skipped ahead there. 1, and then we output 2. Now here's the thing, is now we've run this 3 times. So this for loop, this for j loop, is done running and it goes back to the I loop. Now I loop now increases by 1. So now we're looking at these guys. So then I loop increases by 1. So now we're looking, but j starts back at 0, and we look at the length of the 1 position, and we see that it has the length of 3. So we see down here it's 3. So now we are printing out 1 of 0, 1 of 0. Here's 1, here's 0. This guy right here. Then we run through the loop again. We print out, now j increases, but I stays the same. J increases by 1, I stays the same. So you see I is 1, j is 1. Position 1, 1, that's this whole guy. And location 1 inside of it is this guy. So now we output a 4. And there's our 4 down there. Now we output our last one. J goes up to 2. So we're looking at 1, position 1, and inside of it, the sub position 2. And it outputs that value 5. Now things kind of change because I threw a little bit of a curveball in here, which is why Python is so awesome that you can do this. Not other languages will actually support this type of behavior, but Python does, where we can have mixed dimensional sizes in a multi-dimensional array. So now what we should find is that I is going to go up to looking at the 3rd value. So I is going to turn to 2. Now I is 2. Now we look at, well, what's the length of IList? And this one should actually be IList of I, since I is 2 now. This should change to 4 when I do step over here. But it doesn't. So we've got some limitations here. It looks like when we are working with our multi-dimensional array, we would have to come up with a different mix. Oh no, it actually did it. So it must not have updated correctly in the debugger. That's all. That's fine. Interestingly, that is kind of funny that it didn't update correctly, but it still output correctly the 6, 7, 8, 9. But it didn't update in the debugger. Funny. Okay. I may need to get into that a little bit and play with it, but I don't want to actually take up your time because that should have actually updated to 4 on the last run through. Oh, you know why? This whole time I have been looking at the wrong thing. We we're looking at not the length of ilist of 4. So let's look at this again. We didn't put the whole thing in the debugger. No wonder you guys are probably looking at me a little funny right now. This is the wrong expression to look at. We need to be looking at this guy. Okay, so let's go through. Okay, so first run through, ilist of I outputs 3 as proper, all the way through until we get to where I becomes 2. So I becomes 1 now, and when we get I becomes 2, we're pointing to this last one. So we're coming up where we were at. Okay, we're almost there. There we go. Now I is 2, and this properly len the length of ilist at location 2, see, it comes back as 4. Because it knows that ilist of 2, this guy right here, has the size of 4. And so then it will output all those 4 items. And so it goes through those last 4 items and prints them out. Okay, so guys, this is a really good thing to play with and to get a real understanding of how multi-dimensions work in Python and how powerful it is. It's much easier to work with than other languages because you actually can't do that in other languages. It has to be set 3 by 3, 4 by 4. It can't be mixed sizes here. That would cause some other languages a hissy fit, which is why we use Python for a lot of different things, because it makes these things very easy for us to really get out of the weeds or see the forest through the trees and really develop some high-level code or highly complex code to do highly complex jobs easier. All right, that is our run for today. I'm going to let you guys deal with tuples on your own and matplotlib on your own. We've gotten through the main gist of everything that this chapter has for us. I will be doing a demo on the next video, a demo from probably an assignment starter in your next video. Thank you very much. Goodbye.